Good morning, everybody, and welcome back to class. As you can see on the board, you've had two warm-up questions you should have been working on as we move through the discussion of evolution. These two warm-up questions are, what is natural selection, and what does survival of the fittest mean? We will talk about these two topics in today's notes as we discuss types of natural selection. We're going to focus on three types of natural selection. Those three types are directional, stabilizing, and disruptive natural selection. We will continue our discussion in days ahead with other types of natural selection. Now, to begin with, let's talk about what natural selection is in general. Natural selection is how evolution occurs. It is the mechanism that allows favorable traits to be passed on from generation to generation. First brought about by Charles Darwin. Charles Darwin, in his work, The Origin of Species, first spoke about natural selection. He mentioned that it is also known as the survival of the fittest. It's called the survival of the fittest because those organisms that have the strongest traits, the most positively affecting traits, will survive long enough to mate, to procreate, pass their traits on to further generations. This is going to allow for those beneficial traits to pass on, while any organisms that do not have beneficial mutations, or mutations that are actually negatively impacting them, they generally will not survive long enough to make their traits will not be passed on. The species, the population, then evolves into a stronger and better suited population. Now, as mentioned, we're going to talk about three types of natural selection, these being directional, stabilizing, and disruptive. As you can see here, I've got a graphic that generally describes all three. The top portion of the graphic shows the original population, which is in the general shape of a bell curve. You've got the majority of the population occurring in the center of the phenotypic observable traits, where you've also got a few organisms in the population out towards the extremes. If we take a look here first at stabilizing selection, you will see that the mean of the population after evolution, after selection, has actually increased right here in the middle, while the extremes of the population have shrunk greatly. Looking at directional selection, the mean has shifted towards only one of the extremes, and in diversifying, also known as disruptive selection, the mean, the averages have increased in both of the extremes, whereas the mean or the median has decreased. We'll talk about each of these in greater detail now. The first we're going to talk about is directional selection. Directional selection is natural selection that actually leans towards one of the two extremes in a population. A common example is that of the peppered moth. If you look here at this picture, this is a picture of the peppered moth population in pre-industrialized England. In that time, most of the trees had white bark, so if you look, there's actually a white colored moth right here, and there are black moths as well. It's very easy to pick out the black moths, harder to pick out the white. Because of the difference in color, the black moths were easily picked off and eaten by predators. Those, again, natural selection, that coloring was therefore not passed on to as many further generations, whereas the white color was propagated and passed on. So the general coloring of the peppered moth population was white. However, in post-industrial England, when factories were emitting a lot of soot and smoke out of their chimneys, the tree bark actually turned into a blacker color. Well, then you had the opposite, where the white moth stuck out against the black background and the black moth blended in. It was much easier for predators to pick off the white moths, therefore they were no longer capable of reaching a mating stage, while the blacks were. The coloring of the majority of the population shifted towards the black color of the moth. This is directional selection because the coloring is moving directionally from one extreme to the other. We now have, in England, there is now a much greater black population of the speckled moth, the peppered moth, than there is of the white population. Now, the allele frequency of the selected for trait increases, while the allele frequency of the selected against trait decreases in directional selection. In stabilizing selection, Stabilizing selection is where the most favorable trait is actually right in the middle. That's why the mean population is going to increase in the middle of the bell curve while the extremes are decreased. This causes genetic diversity to actually decrease because selection is for the average in the middle of the road, the most common traits. It's selecting against those extremes on either end. Common example of stabilizing selection is actually human baby weight. Infants or babies that are born with extremely low birth weight are actually more prone to disease, to infection, and typically to a shortened lifespan, some not making it through their child years. While those children with higher birth weights, the mother has a tough time actually going through labor with them and generally results in a C-section. That is why doctors are always trying to stabilize baby as well as mother's weight during pregnancy in order to ease the mother through labor. Again, that leads to a very middle of the road average of birth weights for children because it makes life easier on the mother and the child. Finally, the third type of selection we're going to talk about today is disruptive selection, which you saw on the introductory slide is also known as diversifying selection. Diversifying selection, as stated here, favors the extreme phenotypes of the traits. We're no longer looking at the middle of the road. Now we're looking at the extremes. We're moving to two different sides of the range of phenotypes or physical characteristics. An example, as we have here, is the Galapagos finches that Charles Darwin studied. Disruptive selection is going to lead to speciation within a population because of looking at the two extremes. Here you notice that we have birds with larger beaks. They are more suited for larger size seeds, which typically have a harder shell so they can break through them. And then there are also smaller beak finches. They are better suited for the smaller seeds that are kind of found within pods closer to the ground. It's easier for them to pick up. The disruptive selection does not favor medium-sized beaks because they are too small to break those large and tough seeds that the large beaks can get, and they are too big to pick up the small seeds that the smaller beaks can get. So in this case, again, we're moving away from that middle range. We're moving out to the extremes of either very large beaks or smaller beaks instead of looking towards the middle. That is disruptive or diversifying selection, leading to speciation, different species within the finch family. Now, as a quick review of what we've talked about, first question, which type of selection favors the average or the norm phenotypes of a trait? Anybody? That would be stabilizing selection. Remember we talked about childbirth. We want things to be right there average, right in the middle to even things out. Now, why is the peppered moth a good example of directional selection? Exactly. The color of the majority of the population has shifted from one color, from white, to an extreme towards black because of the difference in environment. Remember, those white moths were easily blending in with the white trees pre-industrial, but they stuck out post-industrial, so they were eaten. They were not allowed to survive, to mate, and pass on their color. And finally, how does disruptive selection lead to speciation? Exactly, it favors the extremes of a trait. So we're looking at the extreme differences within a population, the very different phenotypes. Those in the middle that are normal and average are not going to be selected for. They're actually selected against, creating two different species out of one population. Now, as I said, we're going to continue our discussion of natural selection tomorrow, and during that time, we are going to talk about inter as well as intrasexual selection. I want you guys to think about tonight what those terms could possibly mean, and we'll get back to it tomorrow. Thank you guys. Have a great day.